Hey everyone, welcome back to the channel. So glad you are here. If you are new, this channel is all about making DSA and LeetCode actually make sense. No gatekeeping, no just Google it, just clean, honest explanations. Quick note before we start. This is the episode 3 of the sliding window series. Episode 1 covered what a sliding window even is. Episode 2 covered fixed size windows. But if you are jumping in right here, completely fine. This video works on its own. I will give you everything you need. Now, today's problem. You are in a coding interview. The question appears on the screen. Find the longest substring without repeating characters. You read it. You think, okay, I know strings, I know loops. Let me just check every possible substring. That feeling, that instinct to just brute force it, that's completely normal. That's where everyone starts. But by the end of this video, you are going to look at this problem and immediately see the clean O(n) solution. One pass, no rescanning, no wasted work. And more importantly, you will understand why it works, not just memorize it. Alright, let's get into it. Look at the screen. You can see the string ABCABCBB laid out as an array with two pointers, L and R. That's your window. Right now it hit a duplicate. See the duplicate detected level? That's exactly the moment we are going to learn how to handle. Keep that image in mind. Now, quick context for anyone who is seen episode 2 and a clean introduction for anyone who has not. There are two flavors of sliding window and knowing the difference is actually really important. Fixed window episode 2. Someone gives you K. The window size is locked. It never grows, never shrinks. You just slide a fixed block across the array. Think of it like a camera with a locked zoom. It can pan left and right, but the frame never changes size. Variable window, episode 3. No K. Nobody tells you the size. The window has to figure it out as it goes. It expands when conditions are good and shrinks when something goes wrong. Think of it like a rubber band. Stretch it as far as it can go, and the moment it breaks, you pull it back from one end. Same core idea, a window that moves across data, but completely different behavior. And that difference is exactly what today is about. Let's look at the problem. Okay, the problem statement. Let's read it together. Given a string S, find the length of the longest substring without repeating characters. Simple enough on the surface. Let's make sure we are crystal clear on two things before we move on, because beginners sometimes get tripped up here. First, substring, not subsequence. Substring means the character have to be side by side, no gaps. Second, let's just read the examples. A, B, C, A, B, C, B, B. Length 3. The substring is A, B, C. B, 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 B. Length 1, just B. P, W, W, K, E, W. Length 3, W, K, E. Alright, here is what I want you to do. Pause this video right now. Seriously, I mean it. Look at A, B, C, A, B, C, B, B and think, how would you solve this? What's your gut instinct? Even if you have no idea, just think for 30 seconds. Because that thinking is going to make the solution stick so much better. Okay, let's talk about what most people think of first. So what did you think of? If your answer was something like just check every possible substring, you are in good company. That's genuinely the most natural first thought. And honestly, it shows good instincts. You are thinking about the problem correctly. Let's actually look at that approach. Two loops, one for the start of the window, one for the end. For every substring, check if it has repeating characters. If it does not, update the max. Clean logic. Makes sense. Now let me tell you where this starts to hurt. Imagine you are checking the substring A, B, C, A. You scan through it. A, B, C, A. Duplicate found. Okay, move on. Next iteration, you check A, B, C, A, B. You start scanning again. A, B, C. Wait, you already checked A, B, C just now. You know they are unique, but you are scanning them again from scratch and again in the next iteration and the one after that. It's like reading a book, finishing chapter 3 and then going back to page 1 to reread chapters 1, 2, and 3 before you are allowed to read chapter 4 every single time. That wasted rescanning is what makes this ON cube. And for a 10,000 character string, that's over 100 million operations. Interview strings go up to 100,000 characters. This will time out. So what the smarter move? What if instead of restarting, we just fixed the problem from the left? Here is the moment everything clicks. Stay with me. Picture this. You have a window over string A B C A B C B B. L is at index 0, R is moving right. Everything is going great. A, B, C, all unique. Window is growing. Then R reaches index 3, the second A. Duplicate. Old thinking. Throw everything away. Restart from the next position. New thinking. Wait, the only reason this window is invalid is because A appears twice. If I just remove the first A from the left, the window becomes valid again. So we move L forward. Remove A at index 0. Window is now BC. No duplicate. We add the new A. Window is BCA. Valid. Let me give you an analogy that makes this stick. Imagine you are at a buffet. You have a tray and the rule is no duplicate dishes. You pick up pasta, salad, soup, all unique. Great tray. Then you reach for pasta again. Old approach. Dump the entire tray, start fresh. New approach. Just slide the pasta off the back of the tray and grab the new dish from the front. Same result. Valid tray. But you kept all the useful information instead of throwing it away. That's the sliding window. Don't restart, just shrink from the left. The 4 steps, log these in. Expand, move R right, add new character to window. Check, is this character already in the window? Shrink. If yes, move L right, remove characters until it's clean. Track. After every valid window, update your max. And to check if a character is in the window instantly, we use a set. O of 1 lookup, no scanning. Before we write the clean solution, let's look at the brute force in actual code, just so you can see exactly where the pain is. See that set window call? Every time we check a substring, Python is looping through every character in it again. We are not using what we already know. We are rediscovering it. The logic is correct. The answer will be right. But the computer is doing way more work than it needs to. Time O of n cube, space O of n for the set and substring. Now let's write the version that actually respects our time. Okay, before we look at the code, let's do a full walkthrough by hand. I want you to see the window moving. We are using A, B, C, A, B, the first 5 characters of our example. There is a table on screen with columns step, L, R, char, action, window, and max. Follow each row as I go. Step 1 R0 character A set is empty. A is not in it. Add A to set. Window A. Size 1, max 1. Step 2 R is 1. Character B. B is not in set. Add it. Window A B. Size 2, max 2. Step 3 R is at 2. Character C. C not in set. Add it. Window A B C. Size 3. Max 3. That's our answer right there. We just don't know it yet. Step 4 R3 character A. A is in the set. Duplicate. Shrink. Remove S of L, that is remove A at index 0. Move L to 1. Set BC. Now add the new A. Window BCA. Size 3. Max stays 3. Step 5. R is 4. Character B. B is in the set. Duplicate. Shrink. Remove S of L. Remove B at index 1. Move L to 2. Set CA. Now add the new B. Window CAB. Size 3. Max stays 3. Notice something really important here. L started at 0. It moved to 1, then 2. It never went backwards. R also only ever moved forward. Both pointers travel in one direction, always forward. Combined, they take at most 2n steps. That's why this is O of n. That's the whole secret. Alright, now the clean solution. And I am going to walk through every single line so nobody gets left behind. Let me break down the 4 things that matter most. Char set. This is your live window memory. At any point in the loop, this set contains exactly the characters currently between L and R. Nothing more. It grows when R adds a character, shrinks when L removes one. The outer for loop. R moves forward every single iteration. This is the expand step. It never pauses, never backtracks. One character at a time, left to right. The while loop, and this is important. Why while and not if? Here is the thing. One shrink step might not be enough. Take A, B, B, A. R is at the second B. We go into the while loop. Remove A from the left, but B is still in the set. We need to shrink again. If would stop after one removal and move on, while keep shrinking until the window is genuinely clean. One removal was not enough. While handles that. If would have quietly given you the wrong answer. Right minus left plus 1. This is the current window size. Why plus 1? Because if L and R are the same index, there is still one character in the window, not 0. Quick example. R is at 2, L is at 0. That's indexes 0, 1, 2. 3 characters. 2 minus 0 plus 1 equals 3. Complexity. And I will keep this human, not just symbols. Brute force O(n) cube. We have established why that's painful. Sliding window O of n. Here is why in plain English. R makes exactly n moves, one per character, start to finish, no backtracking. L makes at most n moves total, same deal, only ever moves forward. Put them together, at most 2n moves. That's linear O of n. Think of it like two friends walking the same path. One is a little ahead, one is behind. Both start at the beginning, both end at the finish. Neither one turns around. Together they take two end steps. That's it. Spaces O of mean n and alphabet size. In practice, for lowercase English letters, the set never holds more than 26 characters. That's effectively constant space. So O of n. Brute force, cubic, sliding window, linear. Same problem, same correct answer. Just one of them respects the machine it's running on. Now we are going to talk about edge cases. I know it's tempting to skip this section, but if you are preparing for interviews, this is genuinely where people get separated. Interviewers love asking, "What about this input?" And if you are already thought it through, you look like a senior engineer. So let's do it. Empty string. Return 0, handle it upfront. One line at the top of your function, clean. All same characters, A. Every single R step hits a duplicate. L changes R the whole way. Window stays size 1 forever. Returns 1. All unique, A, B, C, D. The while loop never fires, not once. R runs to the end. Window grows the whole way. Returns 4. Single character Z. R0, L0. Set is empty. No duplicate. Window size is 1. Returns 1. String with spaces. A, B, space and C. Beginners catch this one. Space is a valid character. Your set happily stores a space. A, B, space, C. Returns 4. Don't pre-filter spaces. The problem does not ask you to. The sneaky one. A. R hits the second B. The while loop fires removes A, but B is still in the set. Shrink again, removes B. Now the window is clean. Add the new B. This case is the whole reason we use while instead of if. Pro tip. After you finish your solution in an interview, spend 60 seconds walking through these cases out loud. It shows you think like an engineer, not just someone who passed the happy path. Okay, this is the slide you want to save, because here is something I really want you to understand. This is not just about today's problem. The variable window pattern shows up everywhere. Longest substring with at most k distinct characters. Minimum size subarray with sum greater than equals target. Longest subarray with ones after replacement. All of them same skeleton. What changes between problems? State. Sometimes a set, sometimes a dict with counts. Violation. The condition that tells you the window is invalid. Today's violation is right in char set. Duplicate character. Next problem's violation might be sum exceeds a target or more than k distinct characters. The shape stays the same. You just swap the violation. Once this skeleton lives in your muscle memory, you stop solving these problems one by one. You just recognize the shape and fill in the blanks. Quick look at where we are in the series. Episode 1, what is a sliding window? Done. Episode 2, fixed size window, max sum subarray. Done. Episode 3, variable size window, longest no repeat substring. You are here. Episode 4, minimum window substring, the hard one. Episode 4 is a LeetCode hard. It is the problem where the expand and shrink logic have to work together under a more complex condition. It trips people up in a real FAANG interviews. But if you have followed this series, and especially if today clicked, you will be ready, I promise. We are building this up one piece at a time, and it's all going somewhere. And that's episode 3, variable size sliding window. Expand, check, shrink, and track. If this helped you, if the buffet analogy clicked, or the while versus if thing finally made sense, hit the like button. It genuinely helps this channel reach more people who are grinding through DSA. And drop a comment. What finally made it click for you? I read every single one and I would genuinely love to know. Subscribe so you catch episode 4 when it drops. Thanks for watching. See you in episode 4.